Okay, so solve the differential equation dy dx equals 5x minus 3y all over x. Okay, so analyzing this equation, we can say it is a linear equation. Why are we saying it's a linear equation? Because a linear equation is in the form dy dx plus p of xy equals qx. So linear equation is in this form. So the p of x and the q of x just represent a function of x. So we always try to write our differential equation, the question in terms or in the form this dy dx plus p of xy equals q of x. So upon doing so, we can um compare. We can compare, and before comparing the p of x and the q of x, I know that we can send our terms here minus 3y over x to the left hand side. So when this one comes here, we are getting, when this one comes here, we are getting plus 3 over xy equals 5x. So then we compare the coefficient. So this is y and this is the p of x. So by comparing this equation, the y aspect is this. So my p of x is equal to 3 over x. So and by comparing the q of x is equal to my 5x. Then we find the integral factor mu. So the idea is that we find the integral factor. The formula for finding the integral factor is the e raised to the power integral of p of x dx. So always keep this in mind, the integral factor. Okay, so my integral factor is given by e exponent integral of p of x dx. My p of x is 3 over x. So we make a substitution. Wherever I see p of x, I will substitute 3 over x. So upon doing that, I know that my 3 over x, it can be written as the constant. 3 is the constant, so 3 will come out multiplying the integral of 1 over x. So nothing has done to the equation. This is the same thing as this dx. So integrating ln x, know that this is a function and a derivative. So this is a function. Know that when we differentiate x, we are getting 1. So this is a function and this one is the derivative. So a function and a derivative, we integrate a function with respect to its derivative, we are getting ln x. So multiplying the 3, getting e exponent 3 ln x. Okay. So you know that the ln is written as, or the base of ln is e. The base of ln is e. The base of ln is e. So the base of ln is e. E. So the e will take away the e will take away the base of ln, getting x exponent 3. We had x exponent 3 because from this, you know that from law of logarithm, if we are multiplying a constant by a logarithmic function or a logarithm, normally the one in front will come to the exponent, or the one in front will come as an exponent. That's why we had this x exponent 3. So after that, our mu is x exponent 3. Then that's the integrating factor. Then we try to multiply my integrating factor mu through the original equation, the equation when it was in the form this. So try to multiply through. So upon doing so, my x cubed times dy dx plus 3x squared y equals 5x exponent 4. Okay, so after that, you know that this dy dx, you see, when we differentiate 3, x exponent 3, we are getting 3x squared. So it's more like it's just a product rule, a solution to a product rule. You know that when we differentiate this, we are getting 3x squared. So this can be written as a partial derivative of the product x cubed and y. So for instance, when we want to differentiate x, we keep x cubed constant, giving us this. We differentiate y, then we attach dy dx to it. Then plus, we keep my y constant. This is the y. When we differentiate x cubed, we are going to get 3x squared. So we can replace the whole of this function by x cubed y. Then we try to integrate the whole function. So integrating the whole function is like the function of this has been already differentiated. So when we integrate it, we are getting only the terms within. That's x cubed y. Then we integrate the right hand side to, we are getting x exponent 5 plus c. So we try to reduce it to make y the subject. We divide through by x cubed. So the x cube will cancel the x cube. Then x cube will go into x exponent 5 x squared. Then more or less c will divide x cube, getting cx exponent minus 3. Please, thank you very much.